This video is for section 5.2, direct variation. Our goal for this lesson is that we can be able to write and graph an equation of a direct variation. So let's take a look at the first bullet point. If the ratio of two variables is constant, then the variables form a direct variation. One variable directly affects another by multiplying it by a constant value. And that constant value is going to be the letter K. K is a variable that stands for a number, and it's called the constant of variation. So make sure you're filling in the blanks on your note sheet, and in the rounded box, we're going to write y equals kx. K cannot be equal to 0. And the way that we find out what K is, after you say that K is the constant of variation, you want to write that down. To find what K is, you're going to write K equals y over x. So you want to make sure you write that down. If we're given an x and a y value, we can easily find what K stands for, what it is equal to, if you do y over x. A few real-life examples of direct variation. The first one is if the variables both increase. An example of this would be the more expensive the car, the more sales tax you have to pay. So I actually came across this when I was buying a car recently. The more expensive the car you buy, the higher the sales tax is, which stinks, but that's the way it is. So another example of direct variation, this time when one variable increases, the other variable decreases. An example of this would be, say that the power went out and you were using candles or lanterns or something like that. As a candle burns longer, its height gets smaller, so eventually the candle runs out. Make sure you write those in underneath the examples. To determine whether an equation represents a direct variation, we need to solve it for y. So that's your blank. Solve it for y. In example 1, we're going to do just that. So we're going to get y by itself. And we've done this before in previous chapters. So example 1, does the equation represent a direct variation? If so, find the constant. We need to get the y by itself, so since the 7 is in front of the y, by multiplication we're going to divide by 7 on both sides. That means the 7's cancel out on the left side. Y equals 2/7 x. So we just solved the equation for y, and it is in the form of y equals kx. As you can see, y equals kx. Same exact form. So we're going to say yes, dv. dv stands for direct variation, and the constant of variation is the number in front of the x. Constant of variation, k equals 2/7. You just take a look at the number in front of the x. Now let's look at this next one. On the right side, we have 3y plus 4x equals 8. First thing that we want to do is get rid of the 4x, bring it to the other side. So that means we have 3y equals negative 4x plus 8. Divide all sides by 3. That means the y is by itself now. And we have negative 4/3 x plus 8/3. Question for you. Does this look like y equals kx? Hopefully you realize that no, it doesn't look like y equals kx, so this is not direct variation. So you have an example on the left side of a dv and on the right side of one that's not direct variation. Okay, example 2. Suppose y varies directly with x and y equals 35 when x equals 5. What direct variation equation relates x and y, and after that, what is the value of y when x equals 9? So the first thing that we want to do is find the constant of variation using the ordered pair that we're given. So the basic equation that we're going to use a ton in this section is y equals kx. Hopefully you have that memorized already. If not, get that memorized very soon. Now we're given y equals 35, x equals 5. Guess what we're going to do with those numbers? Well, you probably guessed it. We are plugging those in. So take 35, put it where the y is, and take the 5 and put it where the x is. And now we need to get the k by itself, so we're going to do the opposite operation, which means dividing both sides by 5, and k equals 7. So we just found the constant of variation. Now to write the equation, we're just going to use the y equals kx and put the 7 where the k is. So y equals 7x is the direct variation equation. So check the first bullet point off. Now, what is the value of y when x equals 9? Well, here's our equation. X equals 9. We are going to plug that number in. So y equals 7 times 9, and that is 63. So we just finished the second bullet point. Feel free to pause here if you need to catch up, or rewind if you need to rehear that. Okay. Now we need to know, what does a graph of a direct variation look like? So the graph of a direct variation equation, y equals kx, is a line with the following properties. The first property is the line passes through 0, 0. That's called the origin. It must go through 0, 0 in order to be direct variation. Another property is that the slope of the line is k, because in this equation, the k is the value in front of the x. So if k is bigger than 0, aka positive, the slope, the line, is going to be going up. This is very similar to what we just learned in the last section, 5.1. Now, if the k value is less than 0, that means it's a negative constant, then the graph is going to be going down. All right, we're ready for example 3. This is a real-life application problem, and just in case you cannot see this on your paper, the weight of Mars, the weight on Mars is 50 pounds, and the weight on Earth is 130. So basically, we're going to compare the weight of one person, but on two different planets. And I think this is a really interesting problem. It also shows you the connection between math and science. So let's read this together. Weight on Mars, y, varies directly with weight on Earth, x. The weights of the science instruments on board the Phoenix Mars lander on Earth and Mars are shown. What is an equation that relates weight in pounds on Earth, x, and weight on Mars, y? Well, we're going to be using y equals kx because it told us right here, varies directly. That means direct variation. It's the same thing, just reversed. Direct variation varies directly. So y equals kx, we are given that x stands for weight on Earth, and that value is 130, and weight on Mars is 50. So this is quite similar to previous problem number 2 we just did. Substitute in 50 for y and 130 for x, and get k by itself, so that means we're going to divide 130 on both sides. K equals approximately 0.38. So that means our equation is going to be y equals 0.38x. So if you ever wanted to know what your weight would be on Mars, you can just substitute in your weight for x, and then you'll figure it out. So now we need to graph this thing, and a table will make it easier. So let's make a table. X, y. I'm going to use values 0, 50, 100, and 150. And the way that you find the matching y values is you plug in the x value and do the operation multiplying by 0.38. So we get 0, 19, 38, and 57. Now, feel free to pause this video to label your graph at right. I'll do the same. Okay, now we have our graph ready to go. We're going to plot the points. So 0, 0, 50, 19, 138. I'm getting these from the table that we just made. And 150, 57. And we will be connecting these because it is possible to be between those values. All right, that completes example 3. As you can see, science and math are related to each other, and we just found out the relationship between weight on Earth and weight on Mars. Feel free to calculate your own weight if you're interested. Okay, moving on to the last example. We can rewrite y equals kx as y over x equals k. I talked about this in the very beginning. When xy varies directly, y over x is the constant of variation. So basically what that's saying is it's the k value, and we said that in the beginning as well. So now, example 4, for the data in the table, does y vary directly with x? If it does, write an equation for the direct variation. So what we want to do is take the y value and put it over the x value. So find y over x for each ordered pair. 6 over 4 reduces to 1.5. 12 over 8 reduces to 1.5. And 15 over 10 also reduces to 1.5. So if you get the same number for all three, you're definitely going to have a direct variation. So you can say yes, dv, and the equation, well, this is the k value right here. K equals 1.5. So you just substitute that in for the k value. Y equals 1.5x. That is your equation. Part A is done. Now we're going to do a very similar thing for part B. We're going to do y over x again. So 3.2 over negative 2. That equals negative 1.6. 2.4 over 1 equals 2.4. And 1.6 over 4 equals 0.4. So as you can see, the ratio is not the same number for all data pairs. So that means that y does not vary directly with x. So this is not dv because the numbers are not the same. Now, let me just tell you, I know that you're going to do this not only in Algebra 1 but Algebra 2. So make sure you're paying attention to how to do these problems. This completes this lesson. You can feel free to do 5.2 lesson check, or you can wait until we do similar problems together during class. Just make sure you did this lesson notes and the previous lesson check from 5.1.